Hi everyone, welcome to part 2 of the January 2023 Geometry Regents exam. Number 25 happens to be a construction, so this one will look a little different than my usual solutions. And on this one, we're asked to construct the angle bisector of angle ABC. So I've already gone in and I have bolded the vertex at B just as a little bit of a reference point, and I will be using this safety compass in order to complete this construction. You could certainly use a regular compass as well. So I'm going to take this little gold ring of my compass and I'm going to center it right on that point that we bolded. And I'm going to take my pen or pencil. I do recommend pencil for construction so you can easily erase, or I'm using erasable pen here. And I'm going to find one of the letters here that I want to use in order to draw an arc. The goal is that we want to make an arc that is going to cross BC and BA. Okay, so we don't want to try and make it too big. We want it to try and cross both of those two sides that are adjacent to point B. So there's several that we could pick from in order to achieve this. You could have your compass starting out over here if you want. That part doesn't matter. So I'm just going to pick one here. I'm using letter H and I'm drawing an arc. So I'm going to now bold the 2 points where that arc crossed the 2 segments. Okay, so again, I put the gold point of the compass on B, drew an arc so that it crossed both sides. Okay. Now you're going to pick one of those 2 new points. Okay, so you can either pick this one or this one, and you're going to, from there, put the gold piece of the compass on that point. And you're going to pick a letter again on your compass, and you want to pick one that's close to the other point. It doesn't have to go exactly through it, though it could. But you want it to be more than halfway across. So like if you imagine the distance from this point to this point, you don't want to pick something that's going to be so close to the original point. You want to pick something that's closer to the other bolded point. Okay. And again, there's many correct answers here. And if you're using a safety compass like I am, notice the lettered holes here. Whichever one you pick for this arc, we're going to remember that. So I'm going to pick the one, let's say I'm going to pick the one that's between H and L. And I'm going to make a nice rounded arc there. And if you want, if you think you're going to forget, you can make a little note on your paper that says, okay, I picked the one between H and L. Okay. Now you're going to, remember my gold piece was on this point. Now you're going to put it on the other. And you're going to, using the same exact letter, so I'm using the one between H and L, okay, you're going to make another arc. It should almost look like the middle of a Venn diagram, like these 2 pieces intersect one another. Generally, you'll see 2 intersections. Now notice one of mine is in back of B. One of mine is inside the interior of the angle. It might be on yours that they're both in the interior. That's totally fine. Okay, it just depends on the different measurements we chose to use from our compass. So now based on that, I'm looking for the bisector of ABC. I'm going to use these 2 intersections. And I'm going to use my compass as a straight edge. This is the reason I like the safety compass. I don't need a separate straight edge. And I'm going to connect those 2 intersections. And now I have drawn the bisector of angle ABC. So if I look at this, here, right here is my first angle. Here is my second, and they are congruent to one another because we have bisected the angle here.
Okay, let's take a look at number 26. On the set of axes below, triangle ABC and triangle DEF are graphed. We want to describe a sequence of rigid motions that would map ABC onto DEF. So that tells me that ABC is going to be the pre-image and DEF is going to be the image, the after. So let's start with how we could move triangle ABC so that it lands on top of triangle DEF. And it's important to know that these questions often have many correct answers. I'm just going to go through one possibility here. When I look at this picture, I want to decide has a translation, reflection, or rotation occurred. And I think the most obvious one in this picture is going to be that there's a rotation of some sort because the second triangle is laying on its side. So let's start by working with a rotation. When I'm looking at this, it almost looks like that there was a 90-degree turn. And we have to, anytime we do a rotation, we have to identify what the center of rotation is. So what I'm going to do is I'm going to say, let's make the center of rotation B. And I'm going to draw what that triangle would look like if I rotated it 90 degrees about B. So 90 degrees, and this is 90 degrees clockwise, I should mention. So when we take a look at this, I moved one quadrant over, okay? And again, I moved 90 degrees around point B. Whatever you're moving about, that point is fixed, meaning it doesn't change, okay? So notice how B prime would be the same thing. So now we got the triangle facing the correct way, and we can see, oh wait, we just have to shift it over, and that's going to be a translation. So I want to figure out how many units I need to move. So pick two corresponding points. So let's say I look at A prime and D. We are going to move 1, 2, 3 boxes to the right, and put that back in here, and 1, 2, 3, 4 boxes down. So let's write this out. So the first thing we did was a rotation of 90 degrees clockwise about B. And then we followed it up with a translation that moved the points 3 boxes to the right and 4 boxes down. Okay, and you could write that in word form as well. That would be perfectly fine. So again, notice and take note on this question that there are many correct answers that we could come up with. This is just one possibility. And just a big suggestion for this is try not to just come up with the idea in your head, but actually plot, like I have here, what your first transformation would look like. That makes it much easier to find the second transformation and also to check your work. All right, number 27 is shown in the diagram below. A symmetrical roof frame rises 4 feet above a house and has a width of 24 feet. Determine and state to the nearest degree the angle of elevation of the roof frame. Anytime you see this phrase, angle of elevation, that should be like a light bulb going off in your head that we are going to have to use trigonometry or SOHCAHTOA. But when we've learned about SOHCAHTOA, we've learned that that only applies to right triangles. So what I'm going to actually do in my picture here is I'm going to split this roof frame down the middle, and this is where I get my right triangle from. This is why it gives us this hint in the problem that the roof frame is symmetrical, because now I can actually find the measurements. So I'm going to just redraw this picture off to the side here. I have a right triangle. The base of it is 12, right? It's half of the initial 24. And I know this side is 4. The angle of elevation is this angle here. It's the angle where the triangle starts to go upward. And you can use x or theta, whatever variable you want to find that. Once I have that, I'm going to label my sides. So this is the opposite, adjacent, and hypotenuse. And I see that in this problem, I'm going to be using, when I pick from SOHCAHTOA, I'm going to be using tangent. Tangent is the TOA part. And the reason I'm picking that to use is because I know the length of the opposite side and I know the length of the adjacent side. So I'm going to write that tangent of x is equal to 4 over 12. Once you write this, we have to use our calculator to get the final answer. There's no way to do this without the calculator. But one thing you want to check is if you're in degree mode. Now, you might have a calculator a little different from mine that might tell you right at the top here. You might see the word degree, and that's great. If it says radian, that would mean you have to change it. And if you have a calculator like mine where it does not say it at the top of the calculator screen, we're going to hit this mode button just to the right of the second button. And we're going to see what's highlighted here. So look a couple of rows down and I see the word radian is highlighted. I want to change that. So I'm just using my arrow keys so that degree is highlighted, and I'm going to hit enter. Okay, now I can actually find the measurement. Notice the problem is asking about degrees. That's very important to check on any question. If you accidentally do it in radian mode, you'll probably get a very strange answer that doesn't seem like any of the other trig problems that you've done. All right, to quit out of this, I'm going to hit second mode to go back to my main screen. And since I'm finding an angle, this is an inverse operation. So to find x, I have to do inverse tangent of 4/12. That's anytime you're looking for an angle, you need to do an inverse. So to get that in the calculator, I'm going to hit the second button and then the tangent button, and there's that inverse tangent. Now I can type in my fraction. So 4/12. Hit enter, and we're asked to round to the nearest degree in this problem. So that's the nearest whole number. So x is equal to 18 degrees. Number 28, directed line segment AB has endpoints whose coordinates are -2, 5, and 8, -1. Determine and state the coordinates of P, the point which divides the line segment into a 3:2 ratio. A suggestion I would give everyone studying for the Regents exam, this is a question they ask every single time. All they do is change the numbers. So they'll change the two coordinates, they'll change the ratio, but other than that, the question is asked every single time. So we want to just be really mindful of that and making sure that we know that and we can get our 2 points that way. So I'll actually do this problem utilizing a formula and also using a graphing method. Okay, so notice it says the axes are optional, so you could pick one or the other. I'll show both just for the sake of this video. If I look at the 2 points, I have -2, 5, and 8, -1. I'm going to call those points x1, y1, and x2, y2, and I'm looking for a 3:2 ratio. So here's the formula that I'm going to follow. It's the first number in the ratio, so 3, over the sum of the numbers in the ratio. So the first number in the ratio is 3. The sum of the numbers is 5, so 3/5. x2 minus x1, close parentheses. That basically means we're finding 3/5 of the distance between -2 and 8. And we're going to add x1 to that because that's our starting point. Sometimes you might see this formula written in reverse where it's -2 plus 3/5 times 8 minus -2. That's fine. That's the same thing. Okay. So let's simplify this. So I'm going to go over to my calculator over here, and I'm just going to type this whole thing in. So I have 3/5, 8 minus -2, plus -2, and I get 4 as my x coordinate. And I'm going to do the same thing for the y. It's the same fraction, but now I'm going to do y2 minus y1 plus y1. And I'm going to now type this one into my calculator. And when I do that, I get 1.4. So my two coordinates are 4, my x and y coordinates should say 1.4. So I will say this about this question. I mentioned before that this is pretty much always on the Regents, but it's actually very rare that one of the coordinates is a decimal. That will make the problem much harder to do graphically. So I'll show you and as like a check how to do this graphically, but definitely I would check out one of my other Regents review videos to see a problem that does not come out to a decimal answer, and then you'll see the graphing method works nice. So I'll say this, we should know both methods just as a backup here. So I'm going to plot A, I'm going to plot B. And anytime you're doing these problems, when you're connecting, use a straight edge, make a nice straight line between them. Okay, the line is sloppy, it's going to be harder to figure out where to partition it. So our answer was 1.4. So I'm going to estimate where I think that is on the graph, and it looks like it's right about here. And I want to see, does that partition the line segment into a 3:2 ratio? And it does look pretty accurate from my diagram here that I have that. But what I'm going to actually do is I can check it in terms of the x coordinate, that 4 that we looked at. So the distance between A and B horizontally is 10 units, right? From -2 to 8. So I'm going to, every 2 boxes, I'm going to bold a point. So what I mean by that is at -2, we already bolded 0, 2, 4, 6, and 8. We were already bolded. Now remember, this was our answer for point P. And notice to the left, there's 1, 2, 3 sections. And to the right, there's 2 sections. That gives us the 3:2 ratio we were looking for. Okay. All right, number 29. In triangle ABC, AB is 5, AC is 12, and A is 90. Then it gives us some information about triangle DEF. Brett claims the triangles are similar and congruent, and we want to figure out if Brett is correct. I would say absolutely we need to draw a picture to figure this out. So let's draw triangle ABC, and it tells me that A is 90, so I know I'm looking at a right triangle here. And then I have triangle DEF, where D is a right angle, and E and F are drawn. Now, I notice how ABC is given to us and DEF, so I do want to make the triangles have A and D match and have corresponding locations. Same with B and E, and same with C and F. Now let's put our measurements in. It tells us AB is 5, AC is 12, DF is 12, EF is 13. Do not worry if your diagram is not drawn to scale. Mine clearly is not, but we follow the description of what the triangle should look like and what measurements are there, and that's all that matters. Okay. All right, so he says the triangles are congruent and that they're similar to one another. So I'm going to actually just put this right angle in at D. All right, so I notice that in each triangle, I'm missing a side, right? So I notice in this first one here, I know the hypotenuse is 13. I could do Pythagorean theorem to get that, or you might know 5, 12, 13 is a Pythagorean triple. And that means over on this triangle here, I'm going to get 5. So the triangles are congruent. By either, we have a couple methods here, side angle side and side side side. You could pick either one of those methods here and that would work. All 3 sides are congruent, and we have 2 sides that are congruent and the angle between them, so side angle side would also work. Now, to figure out if the triangles are similar to one another, basically what that means is we need the sides to be proportional. And I can see that that is true here. So the triangles are similar. We could actually give the same 2 reasons. Side angle side and side side side. So Brett is correct. I'm going to write one extra little addition here, that all congruent triangles are also similar. That does not work backwards. Not all similar triangles are congruent, but all congruent triangles are similar. So I'm going to say then at the end, actually answer what this question's looking for, which is Brett correct? And yes, he is. All right, moving on to 30. The volume of a triangular prism is 70 inches cubed. The base of the prism is a right triangle. One leg is 5. If the height of the prism is 4 inches, determine and state the length in inches of the other leg of the triangle. All right, so I see volume, prism. I would go right to my reference sheet and grab the formula that I need. So in this case, it's that volume is capital B times H, and key there is that capital B, that represents area of the base. So I know the volume is 70. I don't know the area of the base. It doesn't tell me that, but it does tell me the height of the prism is 4. So if I divide both sides by 4 here, I get 17.5 to be the area of the base. So the problem is not asking us what's the area of the base. It's asking us for the length of the other leg of the triangle. So let's look at what this base would look like. It tells us the base is a right triangle. One of the legs is 5, and we do not know the other. Area of a triangle, also on your reference sheet, by the way, is 1/2 base times height. I know that this area has to be 17.5. Now, that could be a little confusing because we're using capital B for 17.5 and A, but at the end of the day, those represent the same thing, which is the area of this triangular base. So I'm going to plug in here 1/2. I don't know the base, but the height is 5, and now I'm going to just simplify this. I could multiply both sides by 2. So that's going to give me 35. And these 1/2 and the 2 are going to cancel out, equals 5b. Divide both sides by 5, and I get 7 for the base. And really, I'm going to say that 7 inches is equal to the length of the other leg. All right, for our last question in part 2, triangle ABC is given to us on the axes, and we have to find the area of it. This is becoming a very common question on the Regents as well. And the first thing we want to do is box that triangle in. And when we do that, and we want to make nice straight lines to do this. Okay, I'm going to make mine as precise as I can here. We get these 3 surrounding triangles, and the number of surrounding triangles can change depending on the initial shape. When it's a triangle, you get 3. If it was a quadrilateral, you often get 4, though it could vary. And I'm going to go in and say, let's call this triangle 1, triangle 2, and triangle 3. Okay. The difference between the triangles I created and the original triangle is the ones that I created are right triangles. And when we find area of a triangle, it's 1/2 base times height. I don't know for triangle ABC what the base and the height are because there's no right angle for me to look at. Okay? So what we're going to do is we're going to find the area of the rectangle that we created. Okay, so that looks like it is 12 by 6 and therefore has an area of 72. So that's the area of this big rectangle. Now let's find the area of the surrounding triangles. The area of triangle 1 is 1/2 times 6 times 6, and that's going to give us 18. The area of triangle 2 is 1/2. 6 times 3, that's 9. And area of triangle 3 is 1/2 of 12 times 3, which is going to give us a measure of 18. So to find the area of what we're actually looking for, of area triangle ABC, we're going to take the area of the box, which is 72, subtract out all of those surrounding areas, and we'll go to our calculator. So 72 minus 18 minus 9 minus 18 gives us 27. And now I'm going to put units squared. Area always has square units, and that's the area of triangle ABC. Okay. Head to the next video in this playlist to check out solutions to part 3 and 4.